Welcome everyone to our latest critical conversation. My name is Hayaatun Sillem and I'm the Chief Executive at the Royal Academy of Engineering and the Queen Elizabeth Prize for Engineering Foundation. And it is my great pleasure to be hosting another of these online fireside chats that we run to explore topical issues that are important for engineering and for society. Our overarching goal at the Royal Academy of Engineering is to harness the power of engineering to build a sustainable society and an inclusive economy that works for everyone. And we've been using these critical conversations to look at some of the engineering challenges and opportunities that will be crucial to addressing this goal. Today, we're going to be focusing on next steps for nuclear power in the UK. The UK led the world, becoming the first country to split the atom. This was followed in 1956 by the world's first civil nuclear programme and a nuclear power station at Calder Hall. At its peak in the mid-1990s, the UK generated approximately 13 gigawatts of power from nuclear energy, and today still generates about 6 gigawatts. Of course, energy systems in the UK and around the world are undergoing large-scale change. In the UK, for example, both main political parties have ambitious targets for decarbonising our electricity system. And alongside this, we have to ensure continued access to secure and affordable supply of energy. So many experts and policymakers believe that nuclear energy has an important role to play in our future electricity system. But in realising this role, there will be both challenges and barriers to overcome, as well as opportunities for innovation, both in terms of nuclear technologies themselves and also in the way they interact with other parts of the future energy system, such as with the production of hydrogen, which could play an increasingly important role in our future energy system. So today we're going to be asking, what are the current expectations for nuclear within the energy mix of a decarbonised electricity system by 2035? What nuclear energy technologies should we expect to contribute to our energy mix in the future? Where does the UK have real engineering advantage within nuclear? And where are the delivery challenges for realising this role? So to answer these and other important questions, we've got two brilliant experts joining us in this critical conversation. I'm delighted to be joined first up by Professor Paul Stein and secondly, Professor Paul Howarth. Professor Paul Stein is the previous chairman of Rolls-Royce Small Modular Reactor consortium, and prior to this, he was the Chief Technology Officer of Rolls-Royce plc. Currently, he provides independent advice to investors and companies in low-carbon energy technologies, including nuclear fission and fusion. He serves on several government advisory committees, including being appointed in March 2020 to the Prime Minister's Council for Science and Technology. He lectures on aviation technology, nuclear energy, and systems approaches to decarbonisation. We're delighted that you can join us today, Paul Stein. Professor Paul Howarth is Chief Executive Officer of the UK National Nuclear Laboratory. He has extensive experience in the nuclear industry, covering operations, commercial and research portfolios in the UK and overseas, and has worked right across government, industry and academia. More recently, he's also been heavily involved in research, technology and innovation sector beyond nuclear, and chaired AIRTO, which is the Association of Innovation, Research and Technology Organisations, as well as holding a non-exec board position at the National Physical Laboratory. So we have two experts who are going to help us navigate this really important set of topics. And the way it's going to work is that I'll start by having a bit of a discussion with them, and then we'll turn to your questions. So please do feel free to drop them into the chat at any time, and we will power through as many as possible in the course of our time together. But I think let's start with a bit of an overview. So I'm going to turn to you, Paul Howarth, first, please. Could you just kick us off by giving us a quick introduction on the key technologies that we're going to be talking about today and their likely contribution to the transformation of the energy system?
Sure, thank you, Hayaatun, and delighted to be here today. So many thanks for the opportunity to talk about the future of nuclear. So I guess really as a starting point, the size of the energy challenge that we are facing to really address net zero is very significant indeed. And therefore, it's not just a contribution from nuclear that's going to be needed, but many other energy technologies as well. We need everything working together to be able to address really the challenges that are faced with regards to addressing climate change. With regards to nuclear, there are a number of different approaches that are being taken. And it can to some extent be a little bit confusing to individuals as to, well, what technologies you're actually talking about. Now, of course, there's a major difference between nuclear fission and nuclear fusion. I'm sure we'll get into that during the actual discussion. But just focusing on nuclear fission technologies and the changes that are taking place there. To start with, nuclear has always been a large-scale base load generator for electricity, and therefore large gigawatt plus plants are the ones that have generally been constructed around the world. And we have just over about 400 plants operating, generating around about 400 gigawatts across the globe at the moment. So certainly in the United Kingdom, we are looking at deploying those large gigawatt plants at present. That's what Hinkley Point C is. The government's recently announced with Sizewell C. And of course, we've still got some of the AGR, the advanced gas-cooled reactors that are operating, but they are fairly life limited over the next decade, and hence the drive to look to increase our nuclear portfolio going forward. Beyond that, also what we've been looking at is small modular reactors, and this is something that Paul has been closely associated with at Rolls-Royce. This is where we reduce the overall size of the nuclear plant and look to replicate and modularize the technology as best as possible. And I'm sure we'll get into the reasons why there are advantages associated with that. The next genre after that is advanced reactor systems. So these are all the things that, to be honest, they have been looked at in the past, but now we are reinvestigating those, given the size of the challenge and the opportunity for nuclear to address other aspects such as heat generation. So we have things that historically have been looked at, like fast reactors. There's high temperature gas cooled reactors. There's a lot of interest in molten salt reactors. They need potentially more demonstration to be done. And that's, again, something that the United Kingdom, as well as other countries, are looking at. And then finally is into fusion as well, but I'm sure we'll talk about that going forward. So that gives you a bit of an overview of what we refer to as effectively the 4 different types of technologies that we're looking at present.
Brilliant. Thank you. That's a really helpful starting point. And I'm going to turn now to Paul Stein. What would you like to add to what Paul Howarth has said? And perhaps you could also talk a bit more about what you see as the key opportunities or benefits offered by those different categories of technologies, and what sort of use cases are that we might see them each fulfilling.
Well, thanks, Hayaatun. And I just want to sort of redouble Paul's point that he made at the start, and that's the scale of the challenge. The scale of the challenge is enormous. The Committee on Climate Change predicts that we're going to need a doubling of grid capacity by 2050 to take into account the switch to heat pumps, electric vehicles, hydrogen, as you said yourself, Hayaatun, and industrial decarbonisation. And that takes no account of data centers. And these hyperscale data centers are ramping up in energy requirements. The latest hyperscalers need 500 megawatts to power each one. In fact, the United States now predicts that 19% of all electric demand by 2030 will be for data centers. So that's really just to lay down the landscape of the enormity of the challenge. And whilst some of the intermittent renewables do look attractive right now, wind has got a very attractive levelized cost of electricity, LCOE, but that doesn't take into account the system costs. Right now with wind, when the wind dies down, we have dispatchable gas. When we can't have dispatchable gas anymore because of our carbon targets, or because imported fuels become more difficult to obtain in a future world, the cost of energy storage then becomes a limiting factor. People talk about carbon capture and storage. Again, as Paul said before, we need it all. That'll probably play a part in the mix, perhaps as a stopgap, but it's quite expensive. And so a massive upgrading of our nuclear capacity is needed to meet this load demand and to ensure that we can have electricity with the 5 nines reliability required for these data centers. They can't cope with intermittent energy at all. Nuclear has been pricey up until now, but as Paul alluded to, this generation of new nuclear, particularly SMRs, is designed to change all that. Shall I go on a little bit just to talk about SMR and why that might happen, Hayaatun?
Yeah, I think it'd be useful to sort of flesh out, why do these different technologies offer these benefits?
Yeah. So look, the major point about most of the SMR designs, and there are quite a number of them, but I would say, if I can sort of characterize the likely successful ones, they have no new physics. So it's when the physics is frozen, physics that we know about since the 1950s. And the designs that are likely to prevail are ones that focus rigorously on cost of energy. Energy is a commodity. Customers don't really care how it's made. They care on the price of their electricity. And so the application of modern robotic manufacturing, Industry 4.0, digitization, digital twinning, supply chain development with digital twinning, these are all the key technologies that will bring down the cost of small modular reactors and hopefully get to a price point that is considerably less than the big reactors that we have today. It's all about scaling. It's all about what technologies can we make in the quantities needed to fill that huge energy gap globally.
That's really helpful, Paul Stein. I'm going to keep us moving because there's so much to talk about. But before we move on to the next question, I just wanted to ask you to help us, those of us who are sort of looking at this array of exciting technologies that experts are telling us about, and help us to understand, is it a question of which of these is going to win, or do we need them all? And the same applies to, say SMRs and fusion, or indeed, solar. So if we have other technologies that are in the mix, actually, achieving the kinds of cost and efficiencies that are theoretically possible, faster than expected, do we stop needing these other genres of technologies as Paul Howarth described them as?
Yeah, that's a very interesting question. Look, there's going to be a tension, so I'm not going to give you a precise answer. There's going to be a tension between supply and demand. So eventually, with time, it's the lowest cost sorts of energy that will prevail. So Paul quite rightly referred to the advanced modular reactors. Well, the jury is out, in my opinion, as to whether they'll meet the cost target. I mean, they have very neat ways of producing certain energy vectors, such as hydrogen, but unless they can beat the cost of SMRs that will set a price point somewhere in the 2030s, then they'll fade away. And if they can beat the cost, then they will prevail. But against that, we just are going to have a massive shortage of low-cost energy, particularly in the 2030s and 2040s, meaning there's probably room for everybody. But the ones that will succeed most strongly are the ones that can produce energy most cheaply. In the longer term, as Paul said, fusion is sort of lurking there. Fusion has got tremendous potential. We don't need fissile material, which means the whole regulatory environment is quite different. Fusion potentially can be scaled a lot smaller than fission reactors. But once again, the jury is out. We still have not yet had continuous energy from fusion reactors. So whilst many of us are great fans of fusion, to quote Steve Cowley, who ran the lab where Paul worked at Culham all those years ago, 2050s is a better bet for fusion than 2040s or 2030s.
Great, that's very helpful, Paul Stein. So we've got cost and timeline as two key considerations. Paul Howarth, maybe you could pick up the baton from here. Feel free to add to what Paul Stein has just been saying, but I'd also like you to help us build a bit of a picture of what's happening in the UK at the moment. We've obviously had the recent establishment of Great British Nuclear, and there's quite a lot at play. So could you tell us a bit more about where we are in the UK and where you think the UK has real comparative advantage, particularly from an engineering technology perspective?
Sure, thank you. So just to pick up on what Paul was referring to there, I think certainly if we just look in the nuclear bubble at the moment, I think it is a case that we are looking at a diversified supply of nuclear technologies at present. So we are continuing to pursue the large gigawatt plant build, and they have their advantages. And we have certain locations in the UK where they are best suited. Hopefully, what will happen with the large plants is the more that we understand how to build them, because effectively what we're doing now is re-establishing a whole infrastructure and supply chain for nuclear in its own right. So the early days, there's a lot to get through here for us to get into a position where then we can consistently and rapidly deploy nuclear. But for the large plants, the more learning and understanding that we get, from the early construction, the quicker that will be, the more the supply chain is ready. So there will, I think, continue to be a case of building those large plants. Now, the SMRs, as Paul has referred to, they have advantages as well with regards to being able to construct them in a modular manner, making components off-site, shipping them to site, producing units and getting units up and running. So the capital outlay that you are exposed to at any point in time is lower, and you can start to generate as they start to come online unit by unit. And also, not all of the locations, for example, in the United Kingdom, can take the large gigawatt plants. You can put them into the smaller locations as well. So again, I would see a mix between large gigawatt plants and also SMRs as well. And as Paul has referred to, there's then advanced modular reactors, and some of them have applications with regards to heat generation. More work needs to be done to actually demonstrate the coupling between a high temperature nuclear plant, for example, and industrial applications. It could be manufacture, as we referred to, hydrogen, synthetic aircraft fuel, fertilizer, glass manufacture, cement. All of these are high temperature heat processes. So I think looking forward, we would see a diversified mix. Some of those potentially could also be deployed on large, like petrochemical sites, for example, rather than on nuclear sites in the future. So I don't think that we'd see any one like dominant type of nuclear facility in the future. I think we would see a mix, and that's actually not a bad thing to have that diversification in place. And then, as Paul was referring to, if we moved further out into other energy technologies, again, it's a diversification that's needed. Advantages and disadvantages of solar, biomass, sequestration. It's a sensible thing for any country and any policy, any energy policy, to have that diversified approach in place. For example, we did see in the past in some countries that have, and this is an interesting balance, I think, yet to be resolved, that have a fleet of a certain type of reactor. If there's a technical issue with that, then what's the impact on the rest of the fleet? So fleet advantages exist, but also we need to be careful with regards to that deployment. Now, in terms of the UK, Hayaatun, where we are at the moment, of course, we have a long traditional history of nuclear. We do have an active supply chain that has been working on many different aspects on nuclear. Some of the large components for the gigawatt plant build, though, we can't manufacture those in the United Kingdom anymore. Simply the scale of what's needed. When we look at SMRs, as Paul's referred to, like water reactor SMRs, that gets quite interesting because we very well could be in a position, and I'll let Paul pick up on this, he'll know much more about this than I will, the ability to manufacture all of those components in the United Kingdom. And of course, there is the case that we could have domestic vendor capability for those reactor systems as well. When we start to look at advanced systems, as you referred to at the start, Hayaatun, the UK's had a pioneering approach. We have deployed some of those reactors. We still have a lot of capability. In particular, I think some of the advanced systems, high temperature gas cooled reactors that are graphite moderated. The UK, by quirk of fate, we operate gas cooled reactors. We understand graphite as well. So actually, we do have a number of advantages here that allows us to contribute to all of the genres of technology. And of course, we have column for fusion as well. So I think we're well placed as a country.
Thank you very much, Paul Howarth, for that, I think, relatively positive view of what's happening in the UK. Paul Stein, I'd like to get your thoughts on that too. And, you know, you've got international experience, I know, and probably quite well placed to look at the UK versus the US. What are your thoughts on that international comparison?
Yeah, well, first of all, I completely agree with much of what Paul said. I think his analysis was very good. I mean, ironically, one of the benefits of the UK is we don't have an indigenous large power station manufacturer. So we can sort of reinvent ourselves as a nation and ride on the back of new nuclear, I think, quite handsomely. The UK has got public opinion broadly on side, which I think we shouldn't underestimate. Indeed, around the existing decommissioned plant, public opinion is positively chomping at the bit to be the launch sites for small modular reactors. We've got a submarine enterprise in the UK, which is superb, and currently for reasons that many people will be aware of, is currently very buoyant. We have a world-class science base in the UK, and we have the high-value manufacturing catapults. And as I've said before, this is all about manufacturing technology and the application of every bit of digitization we can throw at it in order to drive the costs down. So, ticks are in many, many boxes for the UK to benefit from this pivotal change into new nuclear, whilst agreeing with Paul, we have to carry on operating the large light water plants because we need energy today. In terms of our comparison with other nations, I mean, one of the things that we need to bear in mind, and again, Paul touched on this, is one of the big changes with SMR is that you don't necessarily need nation state finance. And that's really important, because if a power station costs 20 billion, there's no private equity fund on the planet that's going to be able to invest those sort of sums, particularly if it's taking anything up to 10 years to build it. But if a power station costs 2 to 3 billion and takes of the order of 4 or 5 years, now private equity can step in, because once the first of a kind risk is diminished, and we're producing the 5th, 7th, 8th, 20th, now private equity can take over from nation state sources of finance, and that will be huge. And that's why the market is so significant. So then what we've got to do is look at the role of government in getting over that first of a kind risk. And if you forgive me, I'm not going to comment on the UK process for a number of different reasons, not the least of which that it's an ongoing competition. But I will just highlight what's happening in the US, because I think the US has got it pretty bang on here. The Inflation Reduction Act money that President Biden announced a little while ago is actually being used to underwrite risk of first-of-a-kind SMRs. And that's a very powerful way of using the money. And that means that if private equity selects one design over another or one technology vendor over another, the Department of Energy in the US is prepared to say, okay, well, we will underwrite the risk of the first few. And I think that's a very interesting way of combining private equity and industry with the role of government in underwriting risk. As I said, maybe I'll leave Paul to comment on what's happening with GBM, but I think many other countries are looking to the US as an exemplar of one of the ways that you can actually kickstart SMRs.
Thank you, Paul Stein. That's really helpful, and we're going to come back in a minute to a bit more around some of the investment dimension and things. But so far, I think we've had a relatively positive conversation. We've talked quite a lot about the upside in terms of UK strengths, in terms of what nuclear can offer, whether it's in terms of baseload or kind of diversified supply that builds resilience in the UK, ability to decarbonize hard to abate, energy intensive industrial processes, all of which are really important. And we've also been talking about the strengths of the different technologies. But it is not all plain sailing. And so I would like us to kind of drill down a bit more into some of the key delivery challenges that are entailed in realizing this potential role for nuclear. And also just to thank people who are dropping questions into the chat. Please do. We're looking forward to getting onto those very soon. But I'll start with you, Paul Howarth, just to give us a little bit of an overview of what you think the key delivery challenges are. And perhaps we can bring in one of the questions that's already come in here, which is from Dr. Summer Fareed. And that's speaking to the lack of skilled human resources, Dr. Fareed puts it. So I know that skills is going to come up very soon. So we might as well look at it head on. And Paul, Stein, I'll come to you in a minute. I'm going to go to Paul Howarth first to just have first bite of the cherry.
Sure, thanks, Hayaatun. So yeah, okay. So if we turn to what are the challenges, what needs to be overcome to address nuclear, and I'm going to pick up on a point that Paul made just at the end of what he was saying, which is we need to get into a situation where the private sector feels comfortable in the future in investing and taking nuclear forward. That's the ultimate end game that we need to get to. But in order to get there, I think there's a number of things that need to be put in place. And this is why we need industry and government working together to overcome the initial hurdles that are in place before nuclear then gets, widely adopted, and there's confidence from the private sector for the investment that needs to be made. So some of those hurdles, first of all, everybody wants clarity with regards to investments and timescales, and an understanding of how long is it going to take and how much is it going to cost to get a new nuclear plant up and running. So there's a couple of key things associated with that. One is the licensing process. How long is it going to take? What's the process? How can a potential utility, a vendor, have confidence that they are going to receive a license to construct a new nuclear plant? That's number one. Number two is, what's the financing support mechanism that is in place until we get into this way of working where industry can take things forward by itself. So this is where government needs to look at what sort of incentive mechanisms are in place to help overcome those obstacles and to reduce uncertainty. That's the second one. The third one then is getting the supply chain up and running and making sure that we have the capability in country and the infrastructure and the manufacturing base to be able to deploy the nuclear plants. And that's exactly what's happening at present. That's the third challenge. And again, that requires investment, commitment to make sure it's in place. And the third one, as referencing in the chat, is around skills. So we need people. So really, I think those are the key ones that need to be addressed on the nascent days of the nuclear renaissance that we're facing at the moment. And the skills challenge actually is a very significant one. So the first ones that I've referred to, if government said, right, we are going to go significantly into nuclear, if we haven't got a skilled workforce in place, we're really going to struggle. So recently, analysis that has been done in the United Kingdom, we've set up a specific task force to look at the skills requirement. And with everything that's on at present across all of the nuclear activities, I think over the next decade, it's estimated we could be 100,000 people short of trained engineering-based people working in the nuclear industry. So as good as nuclear may be and addressing all those hurdles, if we haven't got the workforce in place, that's going to be a real challenge. So what we need to do is to identify how can we close the gap on that? How can we attract people into nuclear that may be jumping across from working in other sectors? Not everybody needs to have like a PhD in nuclear physics to work in nuclear. It can often be quite daunting for people to come into the sector. They often think that's the case, go, well, I don't really know much about nuclear. To be honest, it's an engineering industry just like any other at the end of the day. It's a highly regulated industry, but we have lots of highly regulated industries too. So there's a lot of common overlap from other engineering disciplines that are in place. And of course, the skills pipeline for the future through schools, universities, education establishments of raising the profile of the career prospects that are in place and the certainty over the next few decades of careers that exist in nuclear. So there's a lot to do.
A lot to do, Paul Stein. We obviously had Sir Simon Bolham's task force. So are you confident that on the skills side we're heading in the right direction?
Well, I'll just make a quick comment about skills, but also come back to some of Paul's comments, which I completely agree with and want to just redouble some of his points. But on skills, Paul is right. We are heading for a bit of a perfect storm, of needing to support the current fleet, to roll out SMRs with pace, to invest in AMRs and whatever is beyond, and AUKUS, where the UK's sort of contribution to global security has recently been sort of put in the spotlight through the AUKUS program. And I'm obviously very proud that we're a major part of that program, but that's yet another tap into our precious engineering skill base that's required. So the 100,000 shortage, I can well believe, Paul, and I'd support that number. If I can come back to some of the other challenges, Hayaatun, just to sort of perhaps come at Paul's points in a different way. I mean, first of all, Paul is right. The current sort of collaboration between industry and government to get us over the first of a kind risk, so private finance can take over in the licensing process. We do need pace. Pace is everything. We need pace for our energy security, pace because of our sort of ongoing climate challenge, and pace, so the UK can play a part in future technologies such as AI that we talked about earlier on. So pace, 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 and the Academy really does have to keep pressing that really pace has to take precedence. There is still a lot of confusion in private equity and private investment. I gave a talk in the city last week, which is supposed to be demystifying nuclear to try and encourage the big city funds to invest. And I would say still more than half are quite confused about new nuclear and about the investment opportunities. So we as engineers still have to be quite clear that the transitional nature from sort of nation state equals nuclear into private finance equals nuclear, we need to keep screaming that very loudly from the hilltops. And also, there's still a big misunderstanding of the energy system in the UK, and a misunderstanding of what happens now when the wind stops blowing, for example, and a view you can just carry on building out the intermittent renewables, which are doing a great job right now. I mean, it's good that we have so much of the intermittent renewables, but there's a limiting case. And we as systems engineers need to be quite clear with government, with investors, with anyone else that will listen, that when the wind stops blowing, the electricity's got to come from somewhere. And if it costs a fortune to store it, it ain't going to come from batteries. So that message also I see as a challenge that we need to keep shouting loudly. And I think all of the intellectual might of the Academy is needed to try and get that message across.
Well, thank you, Paul Stein. Well, we'll do our best. I'm very keen for us to start bringing in more audience questions. So I'm going to try and take us through these a little bit more rapidly because there is so much to cover. Mia McDonald is asking about SMR risks. He's saying, on the one hand, we're saying it's known, proven technology, alive and well in the naval programme. Yeah. On the other, we're talking about needing taxpayers to underwrite the risk in order for private equity and other investors to become comfortable. So what are the risks that we're underwriting? Paul Stein, I think that's one for you.
Yeah. Absolutely. So it's a very good question. And the answer is right at the top of the list is supply chain risk. Supply chain risk. It's not the technical risk of the reactor bit working. I mean, just to give you a sense of scale, the Rolls-Royce small modular reactor, which I now don't have a personal connection with, but obviously was part of, has got 30 million components. 30 million components. All those components have to be made by somebody. All those components have to come together into one place at the right time. So it's supply chain and integration risk. If we want our suppliers to start investing in modern robotic handling, in digitization, in all the manufacturing execution technologies that engineering has to offer these days, they need confidence and they need to de-risk those processes. So these are the risks. It's like sort of starting from scratch, building a car at 400,000 units a year. The big problem isn't necessarily that the car works; it's that all the parts come together at the same time in the right place. So that's what we talk about when we talk about first of a kind risk.
Brilliant. That's a very helpful clarification. Thank you, Paul Stein. I'm going to build on that, Paul House, with another question from Kath Toombs, which is, what's the potential for UK businesses and SMEs in the development of robotics and other associated technology that can support the nuclear energy sector?
Yeah, well, I think building on what Paul was saying there, for example, on the SMR program, a huge amount of opportunity. As Paul was referring to, the supply chain needs to be established. An amazing number of components, as Paul referenced there, that need to be manufactured one way or another. All of that requires investment by our manufacturing base in the UK. Now, of course, what they need, as well as pace that Paul was referring to, was certainty of orders if they are going to effectively move into nuclear to meet nuclear standards and qualification for making components and convert a production line with robotics. To do that, then they're going to have to make investments, so they're going to need certainty. But all of those components, in one way or another, utilizing robotics is going to be an excellent way of reducing cost and improving quality and certainty of production. Beyond SMRs, there's a whole range of opportunities for robotics in the nuclear industry. We have a very vibrant decommissioning and cleanup program. And so utilizing robotics to work in harsh environments, there's a lot of activity in the UK too. So right across nuclear, there's a whole range of applications for robotics.
Thank you, Paul. I'm going to now skip to Paul Stein, who can build on that with another question that's coming from Paul XL, who's asking, where can AI and robotics help address the challenges to get clean, safe energy available to meet society's demands? So a kind of segue on from Paul Howarth for his last answer.
Well, I'll build really on Paul's point. You know that where certainly robotics and machine learning are playing a massive part is in manufacturing technology. So the ability for a machine learning engine to look at an integrated manufacturing execution system. And I'm very proud of, for example, of what Rolls-Royce has achieved in its aero engine manufacture, where the company makes one very, very complex engine a day, achieves 5 nines dispatch reliability. And all of that is down to an incredibly skilled workforce, but also, you know, the ruthless application of everything that robotics, machine learning and manufacturing execution has got to offer. So as we start ramping up SMR, and nuclear moves from being a sort of cottage industry of individual parts being made at rates of sort of 1 a year into 1 a month, into goodness, 1 a week, 1 a day, who knows, then we can start seeing investment come in. Certainly machine learning has got a huge part to play in manufacturing technology. The ability for a machine learning engine to learn, for example, the wear on a 6-axis mill and start correcting it and applying an overarching view of the end-to-end manufacturing and be able to optimize the cost of that end-to-end manufacturing. So, you know, this is stuff that's sort of just about being rolled out today, and I believe it's going to play a big part in SMR manufacture.
Great, thank you. And what I'm going to do is just give a final bite of the cherry on the topic of technology before we move on to a different theme. Dr. Justin Burrows is also asking what technology development is required to support cogeneration using small nuclear. Paul Howarth, would you like to pick up that one?
Yeah, sure. Thank you. So cogeneration is a really interesting opportunity. And this is where we move beyond just utilizing the nuclear plants for electricity generation, utilize the heat output. There are limited examples where that's done already. So I think in Switzerland, they use district heating from a nuclear plant in the community. And I think there's a proposal in Finland to do something similar. But the opportunity here for advanced reactors is to move beyond the outlet temperature, which is a few hundred degrees C for a conventional light water nuclear plant, to look at moving to higher temperatures. And some of these advanced systems move up to around about 500, 600, even up to about 900 degrees C output temperature. And that's where you can start to get very efficient at utilizing the heat for some of these industrial processes that I noted earlier, like glass manufacture, steel, cement, hydrogen, etc. What needs to be done is really through a confidence, a regulatory and a licensing approach is to demonstrate that that coupling can be done. Because on the one hand, you may have a nuclear plant operating, but now you could have located very close to it a large industrial production process of one form or another. Could be hydrogen, for example. So from a regulatory point of view is understanding how do we make that work? What are the regulatory requirements? So I think it's less about the technology demonstration. I think we're fairly comfortable with that. There are some challenges when you start to get up to those high temperatures with regards to the materials that you'd utilize. But I think you're really into regulatory and licensing space of having a nuclear plant being utilized for a different application.
Thank you, Paul Howarth. I would like to move us across to another issue that I'm sure is on some of our audience's mind. Indeed, Richard Maudley's asking about it. And that's public support for nuclear in the UK. So Paul Stein, you talked quite positively, particularly in the context of SMRs, about enthusiasm from wider publics to have facilities sited in their communities or near their communities. What's your perspective on where we are around public support for nuclear, Paul Stein, and where do you feel that further action is needed?
Well, obviously we mustn't be complacent, and you know, I didn't mean to sound complacent in what I said earlier on. Public support for nuclear hovers sort of 50–60% of the public in favour, and that number seems to be going upwards with time as people understand the link between energy security and nuclear. I think also we need to be a little bit more on the front foot in saying, look, there really isn't a plan B. I was interviewed by a German magazine about 2 years ago, who their first question was a very aggressive, yes, but what about the waste? And my response was, well, have you asked the fossil fuel burning industry, what do they do with their waste? Because they produce a hell of a lot more than we do. In fact, they're melting the planet. And it was as if the questioner hadn't thought of the question. You know, we're building nuclear out in order to be able to switch off burning fossils because our planet is in crisis, as well as having other benefits such as energy security. So I just think we as engineers just need to be a little bit clearer about the fact that we have to have nuclear at scale in order to limit man-made net CO2 rising, because we don't really have many alternatives. That what we're doing now without action is causing extreme weather events that demonstrably are changing the climate of the planet, and that actually the safety record of nuclear is pretty good, and we should be proud of that.
Thank you, Paul. Well, at risk of emulating the German interview that Paul Stein just referred to, Paul Howarth, I do think it's worth us spending a little bit longer on the topic of decommissioning and waste, because it is something that causes a kind of sometimes emotional reaction, actually, when you talk about it. And I'm interested to understand how these different technology genres also impact on what that legacy looks like.
Sure, happy to pick that up. I'd also just like to make a shout out to Richard Maudsley, who delighted to see online. Richard is my old chairman at National Nuclear Laboratory, so I'm delighted to see that Richard is here, and I'm sure he's well known to Paul at Rolls-Royce as well. So delighted Richard is on the call. Yeah, so with regards to decommissioning activities, and this actually does pick up to some extent the point with regards to public support, because it is referenced about where the UK has a very expensive cleanup and decommissioning programme. Now, this is certainly the case in the United Kingdom, but this is for a number of reasons. One is that we started nuclear in the pioneering days, and we were looking at many different aspects of nuclear, and we had a race on for a number of reasons of policy at the time of things that we were pursuing as a country. That includes both the deterrent system, but also the nuclear stations had to run very hard in the 1980s when the coal plants, and we had the coal strikes. So nuclear was really pushed quite hard. This did present an issue for us further down the line that now we're dealing with, which is around the legacy waste management and cleanup activities. If we look at the plants that are being constructed today, decommissioning is taken into account now before the plants are constructed and even at the design stage. So actually, we wouldn't be faced with the large legacy waste management and decommissioning legacy that we have to deal with at present. We really are dealing with historic issues that are separate to just power generation from modern plants. But what is really important, though, is that we do demonstrate before we are pursuing nuclear that at the same time we are addressing that legacy as well, because that gives us our public license at the end of the day to be able to say, look, we can manage this. And to build on Paul's point earlier, nuclear waste is one that we know exactly how to engineer the containment of it. We know how to isolate it from the environment, and the volumes are relatively small when we're comparing to fossil fuel that at the moment, large in volume, cannot be isolated from the environment, and it's affecting you and me, you know, wherever people are on this call, it's affecting us day in, day out. That's not the case for nuclear. But it is really important that we do demonstrate that we can continue to pursue and make progress on decommissioning and cleanup. We are already beginning to see some of the more conventional reactor systems around the world that they are being decommissioned in a very cost-effective and efficient, predictable manner.
Thank you, Paul Howarth. And I would like to jump off from that sort of looking around the world view to just touch on this topic of the geopolitics that now inevitably intersects with all discussions around technology, engineering, manufacturing. We've got obviously that changing our perception of risk in relation to domestic supply and access to fuel from different parts of the world. but we also see intersections when it comes to which companies with which ownership we're happy to see building domestic capability. It also impacts on supply chains for fuels that then are required for our nuclear program. So can I just maybe go to you, Paul Stein, and just get a bit of a perspective from you on what you think are the really key changes that this shifting landscape geopolitically means for the context of today's discussion on nuclear?
Yeah, it's obviously a very broad question, Hayaatun. So I'll just sort of come at it from one particular axis and perhaps how it affects us as engineers. I think there's, no doubt the UK has been through a period of deindustrialization, of a movement to a more service-based economy, a movement of people towards financial services, but also the UK has a very thriving high-tech industry. I think with, again, the coming together of more fractious geopolitics, with us being rather more reticent in dealing either economically or in engineering terms with some nations that we used to deal with the need to increase our national security posture, and also, with the rise of sort of deep tech, like quantum, as you say, that accompanies high tech, the UK is going to have to go through a reindustrialization phase, and I think what I see low-cost nuclear being is it's going to be a part of that shift to the UK's economy. I think if we don't do that, we might well lose the boat and be in economic peril. But the flip side is all of these changes are lining up us as a nation to be more dominant in the sort of the heavier side of the engineering supply chain and in engineering design. And I think we should turn this global crisis into a benefit for the UK.
Okay, thank you, Paul Stein. I realise it was a fairly expansive question, so thank you for giving us a focused answer. We've still got questions coming in, so let's try and quickly power through a couple more of them. Second bites of the cherry here coming in. Richard Maudsley wanting to basically ask how the fact that we don't have a government-owned electricity supply system impacts on our ability to achieve economies of scale when it comes to SMRs. So I think, Paul Stein, that's for you.
Yeah, absolutely. A very good question. And hello, Richard, by the way. So he and I used to work very closely together. Look, this is the way things should work out in an open market economy. That, as Paul and I have said, if we can reach a stage where private equity is investing in the development companies that buy small modular reactors, they are going to want to invest in those technologies which give them the best return on their investment. And I suspect that the way the market is going to shake out is, as Paul says, there will be a variety of different technologies, but not 20 or 30, more like 3 or 4 maybe viable designs in the SMR space. And the markets will end up sorting out the issue of getting the balance right between the diversity that Paul quite rightly talked to earlier on, and yet not getting too diverse such that we don't get the benefits of scale. So I have some faith that as we move away from government finance, this issue will sort itself out. A bit like aircraft types, actually. Similar issue.
Interesting comparison. Thank you, Paul Stein. I'm going to give Paul Howarth a chance to also come back on another question around what the connection is between SMRs and microgrids. So there's a question in the chat which you can see yourself, Paul. Is there anything you'd like to say on that topic?
Yeah, that's an interesting linkage between nuclear SMRs and microgrids. I'm not an expert in microgrids, but as far as nuclear is concerned, it's predominantly a baseload generation that is always on. There are options coming forward to cycle a nuclear plant to follow the demand curve, but frankly, nuclear stations are much better when they're operating on a baseload means, and therefore, to be honest, having nuclear on a large grid makes much more sense to smooth out that demand rather than cycle the reactor, given just the way that they actually operate. Smaller reactors very well could have the ability to work on smaller grids. So there are options for developing nuclear reactors down in rather than the gigawatt size, down in a few megawatts, tens of megawatts, that could be utilized where there aren't the opportunities to be on a grid. So, for example, in certain geographical locations overseas, and it's often talked about in Canada, for example, they are looking at remote communities that could utilize a nuclear plant rather than shipping expensive diesel, for example. So there are ways looking forward. I think we potentially would see a diversification in the future where nuclear does move off just being large base load on like supergrid size, with advanced nuclear moving into much smaller ways of operating on smaller grids, utilizing heat output and not necessarily needing the size of, say, nuclear sites that you have at present. But I think that will occur in the future.
Thank you, Paul Howarth. I'm going to give Paul Stein the opportunity to add anything he would like to, but before then, just advance notice that after this, as we're coming to the end of the session, I'm going to ask you each for your words of wisdom to whoever is going to be the government post the election that we're all expecting to happen this year. So I would like your pithy advice that you would want the incoming Secretary of State for Energy, or the Prime Minister indeed, to be ready and poised to implement on your instruction when the moment arises. But Paul Stein, is there anything you'd like to add, first of all, to the points that Paul Howarth was just making?
Yes, I mean, I would say one other dimension to add to Paul's, and we're talking about microgrids and SMRs and how they might be complementary. I mean, microgrids are fantastic technology as well. And, you know, for those of you that aren't familiar, this is a sort of often an islanded power solution that brings together solar and wind and battery, maybe hydrogen fuel cells and maybe diesel generators under smart control. And very, very popular in Germany for providing off-grid power. Very good, and growing in Africa as well, actually, for supplying sort of small townships. So fantastic technology, and the really good thing about it is it's here and now. It's not sort of 2035, 2032. It's here and now. So you know, we need to support both. But I would say of microgrids, it's energy for today.
Brilliant, thank you. So, Paul Howarth, since you've had the extra bit of thinking time, I'm going to come to you first for your words of wisdom for an incoming government post-election. Okay,
thanks, Hayaatun. So I suppose if I was in the position to be able to set out to incoming government what they should do about nuclear, well, some of the things that Paul Stein's referred to, so I'm going to steal his words: pace, pace, and pace. That's what needs to be done, and it needs to be across, I think, all the genres of technology that we referred to today. Move at pace for deployment of the large gigawatt plants, move at pace for SMRs, choose a number of the AMRs to demonstrate, and continue with the path that we're on as far as fusion is concerned. Coupled with that, I think what's needed is setting out the government has set out a roadmap recently, but to give some clarity as to the future number of plants that we're looking at, because that gives certainty to industry, investors, and supply chain with regards to committing to make the investment that's necessary to effectively gear up, tool up, ready for nuclear plants. So I think it's set out a clear vision of what needs to be done in nuclear and move at pace. And I think stick with these 4 genres of technology that we've been talking about today.
Thank you very much, Paul Howarth. Paul Stein, I imagine there is some overlap in what you might like to say there.
Enormous amount of overlap. I'd use the same 3 words, Paul: pace, pace, and pace. This needs to be almost on a wartime footing. Our need for energy security, our need to decarbonize, our need to upgun the grid massively are all coming together, and we're just being very slow in rolling out this wonderful new technology. We should be right on the front foot as a nation. It really is time to do the right thing rather than do things right, which is kind of what we tend to do nationally. So that's what I would say to an incoming government. And then I would also add to Paul's comment about don't forget all the supply chain as well. If we're going to have tax incentives, R&D credits, whatever, capital sort of incentives, let's sort of really revive the whole engineering supply chain in the UK in a way that's never been done before, using the resurgence of defence industry and the need to tool up for SMRs as the catalyst to really get going with change. And that will help the levelling up agenda and help all sorts of other necessary parts of our national agenda.
Dare I say,
Hayaatun, if I could just add as well to what's been said there, I think this needs a bit like a COVID response. The difficulty at the moment with climate change is it's happening at a pace that isn't requiring that burning bridge immediate response. And I think if we don't have that response and another country does, all of the resources, the people, the skills, the investment, the infrastructure, the supply chain will all move to that country and we could get left behind. So that's a big concern for me.
Thank you so much to both of you, Paul Howarth and Paul Stein. I think that was a very compelling message. I also heard, if I detected it correctly, your desire for us to take a systems approach to the question of how you achieve that pace, which of course is just the sort of message that we here at the Academy are keen to promote and keen to support policymakers in doing. So I think it's one thing to advocate for it, it's another thing to actually practically implement that. But let me thank you both for such an interesting, stimulating and wide-ranging discussion. You did a brilliant job of navigating a very wide range of questions. And thank you to our very insightful array of prompts from our audience. If this conversation sparked your interest or if you have further comments about today's event, please do just take a moment to respond to the survey that's been posted in the chat and will also be emailed to you after the event, because your feedback is really important for helping us to shape and improve future events. We have lots more on the topic of energy. There will be a Critical Conversations mini-series coming in the autumn. We're looking forward to that. And then there'll be an additional event in June, which we'll release further details of very soon. And please do stay tuned, do check our LinkedIn page, and we look forward to seeing you at future events. And you can catch up on all of our previous Critical Conversations via the link that should be in the chat below. But for now, thank you so much to Paul Stein and Paul Howarth, and thank you to all of you for joining us. Take care.